chapter, a brand new topic. We're going to look at these things called polynomials. If you're ever going to be doing higher level math, math 10, 11, and 12, you're going to need to know this stuff. So in today's lesson, I'm going to be just teaching you a lot of new things, giving you a lot of definitions, and hopefully after that, in the following videos, you'll be able to apply what you've just learned. Okay? So I don't know if you remember back in elementary school, but you were asked to play with these blocks. You represented numbers with these blocks. Like the one small cube was a 1, the rod represented like 10 because there are 10 small cubes together, and the big, I guess, square represented 100 because you see there's 10 and then another 10, so 10 times 10 is 100. Well, in algebra now, we're going to do something similar to represent these things. In this case, though, we're going to use what they call algebra tiles. Okay? So yellow in the textbook is what they use to represent the positive tiles. I will use white in my notes. And red, or the dark colored one, I will probably use the shaded or the black ones. That's what I will use to represent negative tiles. So if I have the number 1, it's like that same small square, just like before. So that's same, right? Same. But now that rod became, instead of a 10, it's an x. So that's your variable x. And then x squared, notice it's just the length of x here, and the length of x. So x times x gives you x squared. That's why the x squared is a big square. All right? So knowing this, we're going to be learning some terminology and then using these algebra tiles to represent what the algebra looks like. Okay? So here's some definitions that we're going to use. Okay? A letter that is used to hold the place of a number is called a variable. You've seen these before. A lot of people like to use letter X for a variable, or maybe even Y, or even T. Okay? So those are variables. A mathematical expression containing a variable is called an algebraic expression. So algebraic expression. And you might have seen these before too, and I'll show you some examples. How about something like x plus 5? Or even like this, x squared minus 2x plus 1. Or even something like this, where x is in the bottom. That's perfectly fine as well. That's an algebraic expression. The next one says a number that is not attached to a variable. So just a number by itself is called a constant. So something like the number 2 by itself, or even like negative 5, those are constants. All right? If you look at the previous examples, if you look here, x squared minus 2x plus 1, the 1, because there's no variable attached to it, that's the constant. Okay? Now the numerical factor of a term, or the number in front of a variable, has a special name too. It's called the coefficient. C-I-E-N-T. The coefficient. So here, if I gave you that expression again, the coefficient would be the numerical number in front of the variable. So here's your variable x. Numerical number in front would be the negative 2. That's a coefficient. In this case, the x squared, the number in front is a 1. So that 1 is also the coefficient. Okay. We'll continue. The next one. A polynomial. And this word you'll hear a lot. A polynomial is when you have one term or the sum of difference of many different terms. So examples, I can give you that. That's a polynomial. I know you're thinking, but there's no sum. It's okay, you can have one term, remember? Or we can have something like this. Okay, that's also a polynomial. Now, even as polynomials, we can break that down into different types. So a polynomial with one variable is called a monomial. So as an example, like negative 3x or the number 5. A polynomial with 2 terms. If mono was 1, 2 is binomial. So 2x plus 3. That's a binomial. Or even x plus y. A binomial. 2 terms. A polynomial with 3 terms is called a trinomial. So like x squared minus 3x plus 5, right? Trinomial. Anything with 4 or more, we don't give it a name because we get tired of giving it names. We'll just call them a regular polynomial. Okay? So, I'm going to ask you to turn the page, and I'm going to ask you to try example number 1 now. And really, I just want you to identify all of these things: the coefficient, the variable, the constant, and name the polynomial. Okay, so I'll do the first one with you. Part A here. Here's our algebraic expression, 3x minus 2. What are my coefficients? Once again, coefficients are the numbers in front of the variable. 3. What is my variable, though? Yeah, x. And what's my constant? That's just the number by itself. That would be -2. And then the polynomial, well, name, I see that there are 2 terms. We call this a binomial. Okay? All right, can you try the next one? So, the coefficients. Actually, maybe I'll do that with you too. Okay, I'll just do one. The coefficient in this case, I see there's an x there, so the number in front is a 12. But I also see an x squared, so the number in front of that is -5. Both of these now are coefficients. And so what are our variables? Yes, if you said x, correct, but then the x squared is also another variable. You're thinking, Mr. Lee, it's the same letter. I know, but x squared is different than x. Remember the visual of the algebra tile? Right? X is that rod here. X squared is the square. They're 2 different things, so therefore they're different variables. Your constant here is the last number, -6, and because I see 3 terms, this must be a trinomial. Okay? Why don't you try part C then, okay? And then come back and double check your answer with me. Two-thirds, yes, coefficients can be fractions. The variables are A, B, and C. The constant here does not appear, so you can say none, or you could write down the number 0, and because there's 1 term, this is a monomial. Alright. Okay, good job if you got it right. Now, there are algebraic expressions that are not polynomials, okay? So these are not, okay? So these examples are not polynomials, okay? And those are the ones where the variable is in the denominator. So if I gave you 5 over x, that's not a polynomial. A variable under the square root sign, something like this, root x, not a polynomial. A variable raised to an exponent that is not a whole number. So if I wrote down x to the power of 1/2, not a whole number. Therefore, not a polynomial. Okay? Now, before I stop giving you all these terms, I'm going to tell you one more, because this one appears quite a bit. There's one more term you'll often see, and this is called the degree of the polynomial. Now, what's the definition of degree? It's the term with the greatest exponent in the polynomial. That determines the degree. So in this case, look at these terms. I got x squared, x, and just no x. The largest exponent here you see is the 2, so that's the degree. Okay? And so polynomials can be arranged in 2 different ways. By ascending powers, so going from smaller to larger powers of the variable, such as the following. If I took the same expression, I'd write it as -4 plus x plus 12x squared. Or by descending powers, which would be taking the largest one first, 12x squared, then going small in terms of the power. So, now, understanding that, I'm going to ask you to take these algebraic expressions and just rearrange them in descending order, and then ascending order, and then tell me the degree. You go ahead and try this on your own. Highest power is 2. So when we're descending order, we start always with the largest exponent, so 5x cubed, and then the one after that, x squared, that. The ascending is just backwards. Start with the constant, then with the x, and then with the x squared, and then with the x cubed. Degree 3. Cool. So, I hope you're good, because now I want to go back to what we did on page 1 with those visuals of the algebra tiles, And I'm going to ask you now to turn the page and let's see if we can model them with the algebra tiles. So, notice that the white, or I'll say unshaded tiles will represent positives. The shaded or blackened ones will represent negatives. So, here's my example 3. I'm going to ask you to model this thing. So 3x. So x were those rods. I'm going to ask you to just draw 3 white rods. 1, 2, 3 rods. That represents 3x. And then minus 2, well, that's a number, and the numbers are those small little squares. So 1 small square, 2 small squares. But wait, this is minus 2, so we better shade them in. So let's shade them, make them dark. Okay, that's it. Okay. Next one, x squared. So this is not that large square. That represents x squared. And then over here, minus 4x. So we should be drawing 4 rods. Okay. Notice the rods have the same height as the square. Are these rods shaded or darkened? You say yes, because these are negative. And then plus 3, 1, 2, 3. Okay. In class, I'll let you play with these actual tiles. But right now, just draw them up. Okay. I'm going to ask you to try C and D. Now, don't freak out if we have a different variable, okay? If I have X and Y, no big deal, okay? Just know that, hey, I'm going to go and draw them out. So, negative y squared. Think about what that could be. The y squared must be the box. Yeah. And let's shade in the box because it's negative. Plus 2y's. That must be the rods. Must be 2 of them, which are positive. And then I got a minus 1. So 1 small square. Positive. Done. Same thing for D now, okay? 2a minus a squared minus 1. So 2a, 1, 2, minus a squared. Minus 1. Cool. Now, notice the picture here. Do we have the same tiles in both of these pictures for C and D? Yeah, we actually do. So these actually represent the same thing. I switched up the order, but look, it doesn't make a difference. Okay? So for example number 4 now, I want you to identify the polynomials that can be expressed represented by the same set of algebra tiles. So questions 1, 2, and 3 here in example 4, I want you to draw them out and then tell me which 2 are represented by the same set of algebra tiles. The order could be different, but as long as the set's the same, we're good. Okay. So go ahead and try these on your own, and then you can tell me what the answer is afterwards. Oops, I forgot to shade it in. Is 1 and 2 the same? Very close, except now we have 4 shaded rods in the first one, 4 white rods in the second, so they're not the same. It looks to me that number 1 and 3 are the same. Agree? Okay. So the final thing I want you to do today is just be able to look at the algebra tiles and then come up with the proper algebraic expression. So here we have 1, 2, 3, 4, 5, 6 shaded tiles. So you can go -6. You can use whichever letter you want. So I'll just use X. And then 5 white small squares. So that must be positive. That's 5 of them. -6x plus 5. Over here, 2 large squares that are white, so that's 2 of the x squareds. I count the rods, and there are 8 of them, but they're shaded, so that's minus 6 small squares, also shaded, minus 6. All right, that's it for this lesson. Okay.